Hi students, in this lesson we will focus on three major topics: probability, odds, and expected value. And I will probably break this up into three parts so it's not so long. Let's first talk about probability. The probability of an event is the chance or likelihood that it will occur. For example, if there's a 40% chance it will rain today, there are 40 chances out of 100 that it will rain, which also means there are 60 chances out of 100 that it will not rain. This class will focus on theoretical probability. Suppose there is a situation with n equally likely possible outcomes and that m of those n outcomes correspond to a particular event. Then the probability of that event is defined as m divided by n. So we say the probability of an event is equal to the number of ways the event can occur divided by the total number of possible outcomes. Let's take a look at some examples. Suppose a group of people were asked if they had run a red light in the last year. 318 responded yes, and 225 responded no. Find the probability that if a person is chosen at random, they responded yes. Give your answer as a decimal, rounded to the thousandths place value. So we indicate the probability of a yes using capital P and then in parentheses yes. This is equal to the number of people that responded yes divided by the total number of responses. Well, 318 responded yes, so we have 318, and then divided by the total number of responses, which is 318 plus 225. Simplifying, we have 318 divided by 543. And now we need to convert the fraction to a decimal and round to the thousandths. So going to the calculator, we have 318 divided by 543, enter. Because we have a 6 in the fourth decimal place, we round up to 0.586. Notice the 6 is in the thousandths place value. Now we are done here, but remember as a percentage, this would be equal to 58.6%. A probability can be expressed as a fraction, decimal, or percentage. So just make sure you answer the question correctly based upon what they ask for. For number 2, we're told to use the spinner on the right and write each probability as a reduced fraction. Notice how there are a total of 12 numbers on the spinner, which means there are 12 possible outcomes. So for part A, we want the probability of rolling a 2. And since there's only one 2 on the spinner, there's one chance out of 12 to get a 2, and therefore the probability of rolling a 2 is 1/12. Next, we want the probability of an odd. Half of the numbers from 1 through 12 are odd. The odd numbers are 1, 3, 5, 7, 9, and 11. There are 6 favorable outcomes out of a total of 12. The probability of rolling an odd number is 6 divided by 12, or 6/12, which simplifies to 1/2. Now remember, if you forget how to simplify a fraction on the calculator, you can just take 6 divide by 12, enter, math, enter, enter, and it will give you the simplified fraction. For part C, we want the probability of a multiple of 3. Well, multiples of 3 from 1 through 12 are 3, 6, 9, and 12. There are 4 favorable outcomes out of a total of 12. The probability of rolling a 3 is equal to 4/12, which simplifies to 1/3. By hand, to simplify 4/12, we divide the numerator and denominator by the common factor of 4. And then finally, for part D, we want the probability number is less than 8. Well, the numbers less than 8 are 7, 6, 5, 4, 3, 2, 1. There are a total of 7 favorable outcomes out of a total of 12. The probability number is less than 8 is 7/12. For number 3, we are using a standard deck of 52 cards, which are shown below, where we have 4 suits. We have diamonds, clubs, hearts, spades, and then we have 2s, 3s, 4s, 5s, 6s, 7s, 8s, 9s, 10s, and then we have the jacks, queens, kings, and aces. And we know there's a total of 52 cards, so for selecting one card, there will always be 52 possible outcomes. So for part A, we want the probability of selecting one card, and the probability of the card is a jack. Well, we can see from the list of cards, there are a total of 4 jacks, one of each suit. So there are 4 favorable outcomes out of a total of 52. The probability of selecting a jack is 4 divided by 52. And this does simplify to 1/13. Again, by hand, we would divide the numerator and denominator by 4, or on the calculator, 4 divided by 52, enter, math, enter, enter, which gives us 1/13. Now it doesn't say whether to give the probability as a simplified fraction, decimal, or percent. Notice how this fraction is exact. If we did want the decimal approximation to, let's say, 3 decimal places, we would round up to 0.077. But that would be an approximation, which is why often we give the probability as a fraction, because it's more exact. And 0.077 is equal to 7.7%. For part B, we want to find the probability that if we select one card, the card is a spade. So looking at the cards, here are the spades. There are a total of 13 spades out of the 52 cards, and therefore the probability of selecting a spade is 13 divided by 52, which simplifies to 1/4. By hand, we divide the numerator and denominator by 13. We can also do this on the calculator. And as a decimal, 1/4 or 1 divided by 4 is equal to 0.25, which is equal to 25%. Next, we want to determine the probability that if we select one card, the card is red. Well, all of the diamonds are red. There's 13 of those. All of the hearts are also red. There's 13 of those. So there's a total of 13 plus 13 or 26 favorable outcomes out of a total of 52. The probability is 26 divided by 52, which simplifies to 1/2. Notice how we circled or boxed half of the cards from the deck. As a decimal, we have 0.5. As a percentage, we have 50%. Next, we want the probability of a face card. The face cards are the jacks, queens, and kings. There are 4 jacks, 4 queens, and 4 kings. There are a total of 12 face cards. Out of 52 cards, the probability is 12 divided by 52, which simplifies to 3/13. By hand, we would divide the numerator and denominator by 4, which again you can also do on the calculator. And let's also get the decimal approximation. 3 divided by 13, enter. 3 decimal places is 0.231. We round up because of the 7 in the 4th decimal place. And now let's talk about rolling a fair die. The sample space of rolling a fair die would be the numbers 1 through 6, where the sample space lists all of the possible outcomes. So for part A, we want the probability of rolling the dice once and getting a 4. Well, there is 1 4 out of the 6 possible outcomes. The probability is 1/6. I'm going to go ahead and leave these probabilities as exact simplified fractions. Next, we want the probability of rolling a die and getting an odd number. Well, half of the numbers from 1 through 6 are odd. The odd numbers are 1, 3, and 5. There are 3 favorable outcomes out of a total of 6 outcomes. The probability of an odd is 3/6, which simplifies to 1/2. And next, we want the probability of the number being greater than 4. Well, the numbers greater than 4 from 1 through 6, so from the sample space, would be 5 and 6. 5 is greater than 4, and so is 6. There are 2 favorable outcomes out of a total of 6. The probability of rolling a die and getting a number greater than 4 is equal to 2/6, which simplifies to 1/3. Number 5 deals with an American roulette wheel with 38 slots. So what happens is, at a casino, this spins around, a single ball bounces around, and then when the wheel slows, the ball lands on one of these slots. So again, we have 38 slots. 2 of them are 0 and 00, both green. The remaining slots are numbered from 1 through 36. Half are red and half are black. So we want to find the probability the ball lands on an odd numbered slot. Number 5 involves an American roulette wheel, pictured here below. The way this works in a casino is this spins around, there's a single ball on the wheel, and then when the wheel slows, the ball lands in one slot. And there are a total of 38 slots. 2 are numbered 0 and 00, which are green. The remaining slots are numbered from 1 to 36. Half are red and half are black. We're asked to find the probability of each event below and write the probability as a reduced fraction. So for part A, we want the probability the ball lands on an odd numbered slot. Well, 0 and 00 are both even because they are multiples of 2. So we need to find the odd numbers from 1 to 36. Half of the numbers from 1 to 36 will be odd. The odd numbers would be 1, 3, 5, 7, 9, and so on, all the way out to 35. Again, this list would contain half of the numbers from 1 to 36. Half of 36 is 18. There are 18 favorable outcomes out of a total of 38 slots, or 38 outcomes. The probability of an odd is 18 divided by 38, which simplifies to 9/19. Next, we want the probability the ball lands on a 0. There's only one single 0 on the wheel, and therefore there's one favorable outcome out of a total of 38. The probability is 1/38. And for part C, we want the probability the ball lands on a red. Well, half of the numbers from 1 to 36 are red and half are black, and therefore there are 18 favorable outcomes, or 18 red slots out of 38. The probability of a red is 18 divided by 38, which we know simplifies to 9/19. 9/19. So moving on to number 6. A jar contains 6 red marbles numbered 1 through 6, 10 blue marbles numbered 1 through 10, and 8 black marbles numbered 1 through 8. Let's go ahead and model the sample space on the right. So there are 6 red marbles numbered 1 through 6. There are 10 blue marbles numbered 1 through 10. And 8 black marbles numbered 1 through 8. Notice there are a total of 6 plus 10 plus 8 are 24 marbles, which means there are a total of 24 possible outcomes if we select one marble. So for part A, we want the probability of a red marble. Well, 6 of the 24 marbles are red, and therefore the probability of a red is 6/24, which simplifies to 1/4. Next, we want the probability if we select one marble it's not red. Notice 10 plus 8 or 18 marbles are not red. Out of 24 marbles, the probability of a not red marble is 18 divided by 24, which simplifies to 3/4. Notice how this is also equal to 1 minus 1/4, where 1 represents 100%, minus the probability of a red marble, which would give us the probability of not a red marble. Next, we want the probability of a number 3. There's a red 3, a blue 3, and a black 3. There are 3 favorable outcomes out of 24. The probability of the number 3 is 3 divided by 24, which simplifies to 1/8. And then for our last probability, we want the probability of selecting one marble, and the marble is black. Well, there are 8 black marbles out of 24. The probability of selecting a black marble is 8/24, which simplifies to 1/3. Moving along to number 7, we need to analyze this table to determine the following probabilities. So given a test to a group of students, the grades and gender are summarized below. If one student was chosen at random, determine the following probabilities. Write the answers as reduced or simplified fractions. So notice how we have a row for males, a row for females, and then a column for A's, a column for B's, a column for C's, and then we have totals. So notice how there are a total of 76 students. This will be the denominator for each of the probabilities. For part A, we want the probability one student is selected and the student is male. Well, notice how there are a total of 31 males out of 76. The probability of selecting a male is 31 divided by 76, which does not simplify. Next, we want the probability of a female. We'll notice how there are a total of 45 females out of 76. The probability of selecting a female is 45 divided by 76, which again does not simplify. Next, we want the probability of selecting one student, and the student is male and has a B. So of the males, notice how 12 of the males have a B, and therefore the probability of selecting one student that is a male and has a B is 12 out of 76, or 12/76, which does simplify to 3/19. And again, if we needed to, we can always take 12 divided by 76, enter, math, enter, enter, which gives us a simplified fraction. Next, with the probability of selecting one student, and the student is female and has an A. So of the females in this row, notice 9 of them got an A, and therefore the probability of female and A is 9 divided by 76, which does not simplify. For part E, we want the probability if one student is selected, the student had a C. So looking at the column for C's, it does not indicate which sex or which gender. So there are a total of 27 C's out of 76. The probability is 27/76, or 27 divided by 76, which I don't believe simplifies. Let's check it. 27 divided by 76, enter, math, enter, enter. We get the same fraction back, which verifies it does not simplify. Finally, for F, with the probability one student is selected and they did not get an A, which means in this case they got a B or a C. So there are 29 plus 27 favorable outcomes out of a total of 76, which gives us the quantity 29 plus 27 divided by 76, which is equal to 56 divided by 76, which does simplify to 14/19. Now let's talk about the complement of an event. The complement of an event is the event E does not happen. And we usually use a bar over the event to indicate the complement of an event. And we can calculate the complement of an event by using this formula here, where the probability of the complement of E is equal to 1 minus the probability of E. Remember, this 1 represents 100%, so the probability of an event not occurring is equal to 100% minus the probability the event does occur. So as an example of this, number 8, if the probability of rain is 25 divided by 96, what is the probability of the event of no rain? So the probability of no rain is equal to 1 minus the probability that it will rain, which gives us 1 minus 25 divided by 96. 1 is equal to 96/96, And then we have minus 25/96, which gives us 71/96, or 71 divided by 96. And for our last example on probability, we'll be using this Venn diagram shown here below, where the numbers indicate how many elements, or in this case, how many students are in a particular set. So a survey was conducted at a local ballroom dance studio asking 73 students if they had ever competed in the following dance categories. We have smooth, rhythm, and standard. The results were then presented to the owner in the following Venn diagram. If a student is chosen at random, what is the probability below? So for part A, we want the probability if one student is selected, they did not compete in any of the categories. And that would be these 5 students here. So there are 5 favorable outcomes out of a total of 73 outcomes. So it's important we recognize there were 73 students surveyed. So the total number of students is 73, which will be the denominator in each of these probabilities. So we have 5 divided by 73, which does not simplify. But we are told to write the answers in percent form, round to the nearest tenth of a percent. So first convert to a decimal, to 3 decimal places, and then write the decimal as a percentage. So we have 5 divided by 73, enter. To 3 decimal places, we round down to 0.068, which is equal to 6.8%. Remember, if we want the percent to 1 decimal place or the tenths place value, we have to have the decimal to 3 decimal places. Next, we want the probability if one student is selected, they competed in all 3 categories. Well, that would be this region here where all 3 sets overlap. 12 students competed in all 3. The probability is 12 divided by 73. To 3 decimal places, we have 0.164, which is equal to 16.4%. For part C, the probability of selecting one student and the student competed in smooth or standard, but not rhythm. So smooth or standard would be the union of the smooth and standard sets, but we eliminate them if they also competed in rhythm. So smooth or standard, but not rhythm, would be this set here. We eliminate those that are in the union of smooth and standard that also competed in rhythm. So we're looking at this set here, and notice how there's a total of 10 plus 14 plus 8 students that competed in smooth or standard but not rhythm. 10 plus 14 plus 8 is equal to 32. There are 32 favorable outcomes out of a total of 73. 32 divided by 73. To 3 decimal places is 0.438. We round down because of the 3 in the 4th decimal place. So 0.438 is equal to 43.8%. And for our last example, we want the probability of selecting one student, and the student competed in rhythm and standard, but not smooth. So rhythm and standard is the intersection of rhythm and standard, which is this region here, but we do not want them if they also competed in smooth, so we don't count these 12. We're only considering this set here. Again, we don't include these 12 because while they are in the intersection of rhythm and standard, they also competed in smooth, and we want them not competing in smooth. So we have 13 favorable outcomes out of a total of 73. To 3 decimal places, we have 0.178, which is equal to 17.8%. Okay, we'll stop here for probability. In the next part, we'll talk about odds. I hope you found this helpful.